Have you ever stared up at the night sky and wondered, how does it all end? Not with a bang, perhaps, but with a whisper. We're about to embark on a journey to the very edge of time, to witness the final silent moments of our universe. Forget everything you think you know, because what lies ahead is more mysterious, more awe-inspiring, and more profoundly strange than anything we can imagine. Let's travel forward in time, far beyond the lifespan of humanity, beyond the burnout of our sun. 1 trillion years from now, the night sky will be a very different place. The once familiar constellations will be gone, their stars long since extinguished. The majestic swirl of the Milky Way, our cosmic home, will have merged with Andromeda, our nearest galactic neighbor, to form a single, colossal galaxy nicknamed Milkomeda. For a time, this new supergalaxy will burn brightly, a final burst of star formation lighting up the encroaching darkness. But even this brilliant display is temporary. The fuel for new stars is finite. One by one, the last stars will flicker out, leaving behind a graveyard of stellar remnants, cold white dwarfs, dense neutron stars, and the silent, invisible voids of black holes. The universe will enter what scientists call the degenerate era. It's a period of unimaginable cold and darkness, a cosmos populated only by these dead stars. Slowly drifting through an empty void, the universe will become a vast, silent mausoleum. There is no light, no warmth, only the crushing cold of near absolute zero. Yet, even in this seemingly eternal night, the story isn't over. On timescales that are almost impossible to comprehend, even these degenerate objects will begin to decay. Quantum mechanics predicts a phenomenon called proton decay. Over countless eons, the very particles that make up matter could slowly unravel, dissolving into light and energy. Imagine a white dwarf, the dense core of a long-dead star, slowly evaporating over trillions upon trillions of years, particle by particle, until nothing is left. It's a process so slow it makes the aging of stars look like a fleeting spark. The universe is literally unmaking itself. As matter itself dissolves, only one type of object will remain dominant: black holes. These gravitational titans will be the kings of the late universe. They will continue to slowly grow, swallowing any stray matter, any rogue planets, any dead stars that drift too close. For an almost infinite amount of time, the cosmos will be the black hole era, a universe of nothing but isolated black holes, separated by unimaginable distances, floating in a sea of low-energy radiation. It's a truly alien concept, a universe without stars, planets, or even atoms as we know them. But even black holes are not eternal. The brilliant physicist Stephen Hawking discovered that black holes themselves are not truly black. They radiate. Through a process now known as Hawking radiation, black holes slowly lose mass over incredible spans of time. It's a cosmic leak, an impossibly slow evaporation. A solar mass black hole would take an eternity to disappear, but a supermassive black hole, millions or billions of times the mass of our sun, would take even longer. We're talking about numbers so large they have no name, a 1 followed by 100 zeros, a googol of years. As the last and largest black holes finally evaporate in a final, weak flash of light and particles, the universe will enter its ultimate stage, the dark era. What's left? A cold, dilute soup of photons, neutrinos, and other elementary particles, all drifting aimlessly through an ever-expanding, near-perfect vacuum. The universe will be almost completely empty, dark, and cold. All organized structures will be gone. All memory of the brilliant, star-filled cosmos we know today will have been erased. Time itself loses its meaning when nothing happens. It's a state of maximum entropy, the ultimate heat death. This is the most widely accepted scenario for the end of our universe. A slow, cold fade into nothingness. No dramatic crunch, no cataclysmic tear, just a gradual descent into eternal darkness and silence. It's a humbling and perhaps unsettling thought. Everything we see, everything we are, all the achievements of civilization, all the stars and galaxies, all destined to dissolve into a featureless void. It gives us a profound sense of perspective. Our lives, our history, our entire planet are just a fleeting moment in the grand cosmic timeline. But what if there's a twist? Science is a story of constant discovery, and our understanding of the universe is always evolving. Some theories propose other, more dramatic endings. One is the Big Rip. In this scenario, the mysterious force known as dark energy, which is causing the universe to expand at an accelerating rate, could grow stronger over time. If it does, its repulsive force could eventually become so powerful that it overwhelms everything else. It would tear apart galaxies, then solar systems. It would rip planets from their stars, and then, in the final moments, it would be strong enough to overcome the forces holding atoms themselves together. The very fabric of reality would be shredded. Then there's the Big Crunch. If the density of the universe is higher than a certain critical value, gravity could one day halt the expansion and reverse it. The universe would begin to contract, slowly at first, then faster and faster. Galaxies would rush toward each other, merging in a chaotic, fiery cosmic pileup. The temperature and density would skyrocket. The entire cosmos would collapse back into the infinitely hot, infinitely dense singularity from which it was born. And what then? Could this be a cyclical process? A big bounce, where a new universe is born from the ashes of the old, destined to expand and collapse again and again in an eternal cosmic cycle of death and rebirth. Thinking about the end of the universe forces us to confront the biggest questions of existence. What is our place in this vast, evolving cosmos? What is the meaning of a finite existence in an infinite expanse? These aren't just questions for scientists and philosophers. They are questions for all of us. Looking at the silent, twinkling stars, we are looking at both the distant past and a clue to the ultimate future. We are part of a story that is grander and more epic than any we could ever write. And while we may never know the definitive ending, the journey of discovery, the act of questioning and wondering, is what makes our fleeting moment in the cosmic spotlight so incredibly precious. Thank you for joining me on this journey to the edge of time. If you found this cosmic exploration as mind-bending as I did, consider subscribing for more journeys into the unknown. Stay curious,